Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we're gonna talk about the last topic in this chapter, which is test-driven development, TDD, or sometimes it's called test-first development. Test-driven development is proposed in the agile development methods, and specifically in the extreme programming. In test-driven development, we write tests before starting write the code. Usually, we write a code, then we test the code. In test-driven development, no, it's the opposite. We write a test before having anything written related to the code. And then passing that test is gonna be the critical driver of development, which means tests are written before the code, and passing the test is the critical driver of the development. So, if I need to start programming function or something, I need to write a test for that function. When I write the test, there's no source code written for that function. Basically, the test is gonna fail. Then I need to write the code in order to make the test pass. So we develop a code incrementally along with the test for that increment. And we don't move on the next increment until the code that you have developed passes this test. Imagine we have two functions. We start the first function. We start with the function 1. So we write first a test for that function. We run the test. The function is gonna be fail because there's no source code written for that function. So we start writing a source code for the function 1. We need to keep writing the source code in order to make the test pass. We can't move to the function 2 without making the test for the function 1 passes. And as you know, test-driven development was introduced as a part of agile methods such as extreme programming. However, it could be implemented in other plan-driven development processes. The model shows how test-driven development works. First of all, we need to identify the requirements or new features or functional requirement. Then we write the test before writing the code. We run the test. Basically, at the beginning is gonna fail. So we need to implement the functionality and refactoring. We return to the run test. If it is fails, we need to go to the implementation process. We keep in this loop until the test is passed. When it's passed, we move to the next requirement or to the next functionality. So, test-driven development consists of 5 steps. Step 1 starts by identifying the increment of functionality, which means here we need to determine which requirement, which functional that is required to be developed, and so on. This should normally be small and implemented in a few lines of code. Then we write a test for this function and implement it as automated tests because this is driven development. At the end, we're gonna have a huge number of test cases, so we need an automated test harness or test framework in order to reduce the test execution time. So we write the test. After writing the test, we need to run the test. At the beginning, the test is gonna fail because there's no source code written for that test. Along with all other tests that have been implemented, initially you have not implemented the functionality, so the new test will fail. Then we implement the functionality and rerun the test. Here we need to write source code to make the test pass. Once all tests run successfully, we move to the next functional requirements or features or increment. Benefits of test-driven development. The first one is code coverage. So we guarantee that every line of code has a test related to it. Every code segment that you write has at least one associated test. So all code written has at least one test. Here we can guarantee and make sure that every line of code has at least one test covered. Regression testing. Regression testing is a kind of testing that is used when new modifications or changes have implemented in the source code. We use regression testing in order to make sure that the changes or the new requirements or new modifications do not produce errors in the previous version. Regression test suite is developed incrementally as a program is developed. I think there's a next slide or a slide ahead talks about regression testing. Simplified debugging. Debugging here means we need to locate where the error is. When a test fails, it should be obvious where the problem lies. The newly written code needs to be checked and modified. Yeah, because we don't move to the next increment until we make sure the old test has been passed. So if we have a problem, the problem is gonna be in the latest version. System documentation. The tests themselves are as a form of documentation that describe what the code should be doing. Here the test case is gonna be a documentation for the requirements. Regression testing is testing the system to check that the changes have not broken previously working code. In other words, you are working the software. You developed the software, and if you need to improve or update some functionality in the software, it might harm the previous one. In a manual testing process, regression testing is expensive, but with automated testing, it is simple and straightforward. All tests are rerun every time a change is made to the program. Here, it means that we need to use a testing framework such as JUnit in Java or UNit in C#. Tests must run successfully before the change is committed. So when you change the software, you need to run all the previous test cases in order to ensure that the changes that you have made didn't incur or didn't provide or produce an error in the previous releases. User testing. In user testing, there are three different types of user testing, and this kind of testing is going to be carried by users. The first one is called alpha testing, where the user of the software work with the development team. So the user is gonna be a part of the development team to test the software at the developer side. So when we are testing the software by the user on the development side, is called alpha testing. Beta testing is a release of the software is made available to users to allow them to experiment and to raise problems that they discover with the system developers. So it's gonna be not on the developer side, it's gonna be given for the expected users or customer to try it and then provide the feedback to the system developers. Acceptance testing Here, customer tests a system to decide whether or not it is ready to be accepted from the system developers and deployed in the customer environment, primarily for custom system. This is the acceptance test is mainly used in the custom software. Acceptance testing process. This slide shows the processes in the acceptance test. So at the beginning, we need to identify the criteria of acceptance test. Each test, unit test, use interface test, integration test, system test. Before starting the test, we need to identify the criteria. Then the output of this process is going to be test criteria. And this test criteria is going to be as input for the planning acceptance test. The output is going to be a test plan. Then from the test plan we derive the test cases. So the test cases are derived from the test plan, and after that we need to run these tests on the system, and after running we will get a result. So we negotiate the results with the customers, and then we provide testing reports. Based on this testing reports, we can accept or reject the system by the customers. Shows the processes in the acceptance test. As we said in the previous slide, we have acceptance criteria, planning acceptance, derived acceptance test, run the acceptance test, negotiate test result, and the result is going to be either to reject or to accept the system. In the agile methods, the acceptance test is gonna be by the user. As you know, in the extreme programming or in agile method in general, the user or customer is gonna be a part of the development team, and one of the responsibility is to make a decision on the acceptability of the system. So the user is gonna be responsible to define the test and integrate it with other tests which are run automatically when changes are made. So there's no separate acceptance testing process in the agile methods, but the main problem is whether or not the embedded user is typical and can represent the interests of all system stakeholders. As we know, in the agile methods, the user is going to be working with the development team, but is this user gonna represent the whole stakeholders, the whole users? I think this is the main problem of acceptance tests in the agile methods.